I just would like that you know, so that we're trying to record those talks and put them public, so that people can have a bit more awareness about this type of technology and how they work, and not be as much scared of it. So yeah, thanks a lot for letting us filming around and presenting that. So we are going to speak about what's meaningful data, or I could say as well valuable data. A lot of people say, well, yeah, there's a lot of data, you harvest them, and what do you do with it? And really it's like mining, you know. There's some people that just see a piece of rock, and there's some people that see gold. But you need to process it to be able to get the value out of it. So. Come on. So my name is William Pagnon from Freelance Robotics. We are based in Kapalaba. We are specialized in automation, manufacturing. We can either do a single unit automation, or the whole lot as a smart factory, totally automatized, from automated forklift, automated raw product processing, product manufacturing, storage, automation, and loading and unloading trucks. So we as well provide custom solution. If there is a machinery you are looking at that doesn't exist in the market, we can build it from A to Z. We're not just integrator, we are actually able to build a robot from A to Z. What we can do is not just robotics, it's software development. We know over 20 programming language. PCB board, we can design custom PCB boards. Mechanics, we can do molding, extrusions, and so forth. We don't manufacture them, we have manufacturers that do that for us. We design it for you. The other things where we're really good at is control, artificial intelligence, software as well. And so as you can see, there's a lot of variety. Basically it's robotics, but there's also sub-engineering fields that are related to it that we can do. Sorry. So harvesting the data, I really like OMRON picture there, so I pick it back again, and you can see, as Young was explaining really well, how as an NG controller and systematic technology can really simplify your life. To harvest this data to a standard database system where you can have software programs that can extract this data and make it meaningful for what you require to get them for. And that's what I'm going to speak about, is what do you require them for, right? So here, as you can see, you can either store them locally, you can get them in the cloud, depending on what's the type of space. If you have several factories, for instance, it can be interesting to be able to do comparison between factories and so on. Each factories are different, actually within the same product, within the same type of industry, or the same society, who have several factories. They would produce the same product. They would have it's like a ship, you know? They all have their own identity. They all breathe differently, and depending on which people are in there, it works more or less depending on how it is handled. Here's the data. It's to kind of understanding better the plant. See how the plant works, and trying to be clever about it to take off all the bottlenecks, the hurdles, so that you have a streamlined production which reduce waste and improve efficiency plus the quality of work, that everybody benefit from it because you get rid of the painful work and can focus on quality and a much better and interesting task that people have to do. So they're more interested, so they as well, again, do a better work at it. So the system is quite basic of data mining. You get the data harvested from NG and that have been stored in a database. So then you can visualize them, like in the software where you was doing the query and things like that, where you can have a look at it. And then you can as well start to use some models. Like here, there's some example, time series, cluster, naive Bayesian network. Those are techniques that are used in data mining and artificial intelligence to be able to find something that is striking, that's it's either abnormal or they're all the same, that you can order them by category or repetitive. So for example, the time series is more something, oh, that's happened every so often, why? And what's the common point of it? Cluster is all those look to have the same pattern. And you can then start to understand why they have the same pattern. Then you have the naive Bayesian, which is more an adaptative thing than say, if we take that much time to do this, and that much time to do this, and that much time to do this, what is the best trail to optimize your production time? Here's some a bit more detailed example, and underneath I have put some example of what can the system can be used. So you have a classification. So you can look at what's the similar codes that provide quality issues, for example, on your products. Anomaly detection. For instance, if you have something that's slow down, a pressure that vary in one of your system, you can do preventive maintenance and realize that there is an anomaly coming up, and it's identified, and it's telling you about it without you to try to look for it. Clustering, so that's what I was speaking about, making a group of process types. So when you are manufacturing different products for different clients, you look at it and they all look quite different, but in fact they might have common points. Some have, some don't, and generate something that manager would have to do manually and try to find something by themselves. Here you can automatize the process and just having a much clearer picture with drawings and graphs and things, so that you can see what type of product are similar patterns. So for instance, would be good to run those batch together at the same time because they have the same type of setup that are required. Regression, that's another technique, and here you are looking for the absolute minimum of what's happened. So over an history of time, you look at what have been the best optimized process, and so then you can dig into it and you look at why and why it was quicker. Is it the time of setup of the tool? Is it the change? Is it the way people have been trained on it? And all those kind of questions can rise up from it. So attribute of importance as well, where you can see, for example, the result of cost per product compare to time of production and the number of units that are produced or sold, and see which products have a much better reason to focus on and make some effort on. That's just an example, but from all those type of amount of data that you harvest, that it's from the machinery or the management, the things as well is that you can go as far as you want. You can combine it between sales, production, management, and get a real vision of actually what the plant is behaving on, and be able to establish a real-time understanding of the health of the factory. And so you can see the link between the sales, between the delivery, between the production, and see where are all the bottlenecks, or you can make it work together, or you can connect things together, because that's what it is. It's all about connectivity, and often what our motto is embracing the fourth industrial revolution, and the reason for it is because what's coming in as an industrial revolution is that we are connecting machines together, and how we are able to do that is by exchanging data between the machinery using some tools such as NJ and Sysmatic. So it's here, and it saves a lot of time and money, allow you to have a much clearer vision of what you are doing without just do some trial and error, but actually having some information about it. The other things as well is that this is analyzing the past, what's have been done before, and you look at the data of what has been done. It can as well help you to do projection. So with a time series, for instance, if you look at some evolution of pattern, or you can identify a period of sales of certain products up and down, or production of products up and down, or time delay of certain material delivery at a certain time of the year, for instance. Things like that can help you to see ahead what's going to happen, and you project that over the future and say, okay, well, we better, for instance, order a bit more now so that we are not locked later on, because from the last years, the last 2 years, 3 years, we can see that that the trends that it follows. I mean, some people do that manually on through Excel spreadsheet and things like that, but you can have it without have to struggle either. Association, that's another thing as well, of see what together give a better, efficient process. Sometimes for a certain product, one method of producing the parts can be more efficient than on another way, and you can see this combination of process going together. So here's just some example of what you can do with data. So the thing is, you can have all the wishes that you want, trying to have a look about what this data is doing. If you don't have the proper manufacturing mentality and actually adapt the business strategy to the data that's coming, it doesn't work together. So that's where there is a kind of a method. You need to know what you want to measure. Each factory, again, as I was saying, are quite unique and different. So each factory need to do the work saying, okay, so let's prepare a plan saying that we need to measure this this type of machine, the I don't know, labor per dollar per product, labor dollar per product, for instance, or setup time. There's so many variables that you can look at. Maintenance problem, repair, how long downtime we have. Whatever you have a problem with, that's, I guess, where you want to focus first. You have to look at the pinpoint, what's the bottleneck, and start to resolve those first. It's after nothing to just take as well and say, okay, let's all do the all automation of data and connectivity in one go. You will drown yourself. The thing is, you're better off like integrate an NG system so that you can have the data getting harvested and then say, so what data we are interested first to mine and get profit out of it, and so that we can resolve problem from the factory to do so. So then once you do that, you know what you measure and you know what you are going to look for. So you do the measurement, and then all those algorithms I was speaking to you allow you to understand the results. Once you have understand the results, you take action in the factory to improve the production system, and so on. Then you say, okay, next plan. So that's working, not working. Why? Let's make another measurement plan. Make sure that we get those measures coming in. So you look at all the variables that should be taken in consideration and get them all. Analyze the results and improve the factory, and so on, and so on, and so on. And so that's how you're getting better and better at it. It's a bit of a more detailed explanation of the same concept, where sorry, you have the raw data collection that you get from NJ, and then you need to do the data cleaning and transformation that we can do, for instance. All right. Then you look at having your parameters put together so that it fits your model of your factory. And then that's where you get all the graphics, and you say, yeah, but it depends of the period of time, the products, and all those type of things, so that you have meaningful data extracted from. From there, you deduct some solution you could do to improve your factory. So you act on it, do the implementation, get the feedback, and that's as well really important. You need to have the feedback from bottom up. Often it's the people that are on the floor of the factories that can tell you what's actually meaningful to measure, where are the problems, before you go back from a top-down solution and implement some alternative to the production. So you get all those feedback, the feedback from the people, the feedback from the data, and you look at the solutions that come to it, and just go back to the management. And you decide next plan, what's the type of raw data you go for. Okay, that leads us to what we call e-manufacturing. So e-manufacturing is really the future. People that will not go towards this soon will be over by their competitor really soon. There's no question about that. It's like if nowadays you would like to build a product without a machine because you want to keep traditional, you will not be able to sell your product. You would have to close your door. And that's the same things nowadays going to be totally democratized everywhere, and because you save so much cost doing so, and you are much more efficient. Plus, it's allow you to be able to make what they call like one lot production, which is a totally custom product, because you get so much data and feedback and be so reactive that you end up being able to do small batch at the cost of a large batch. And that means that you increase the amount of client for who you can deliver. And yeah, so that's what's going to happen, that we want it or not, we cannot fight progress. So here there is the yellow part and the blue part. So the blue part is more the material part of it, which is the raw material, ordering the material, then there is the factory in itself, the production and all that, then the storage, the inventory, and then the shipment. Note that all that can be automatized. And that it was showing here, using big data. You don't even have to think about it. It's all will be done in the background automatically, so you can focus on much more meaningful part of the business. There is a lot of things going on there, but basically you can automatize the process of ordering material according to the demand. There is different problem of inventories that you can sort out by being able to ship the goods at the right time as well. So there is all those data you can harvest at different parts of the company, and between forecasting demands, because you can analyze the previous data and be able to see that there's a big likelihood, and statistics, that's another big part that we use in data mining. So there's a big likelihood that you're going to have an order about that time of the year. Or you can optimize the design as well to make it manufacturing ready. So that's a really good reason as well to do some measurement to improve the manufacturing, so that you can have something that it's much more fitted to your machinery. And actually, through this analyzing process, you are able to see what went wrong in the design and why, and you can analyze it so that the next design of the product is optimized, and it's a tool to focus on what the issues are, and help you to put the lights on certain things that a lot of time people just leave on the side and don't look at it, and just run on one leg, you know. It's run, but until there's other people that run on two legs and over you really easily. And so, but it needs this willingness to want to progress, to change, to evolve, and have a constant questioning of what can we do better. And so and it's involved everything: quality control, process control, statute reporting, customer services. So you can have every part of that in the feedback loop, in the data, melting everything together so that you have something really meaningful that come out of it, that none of us can just integrate all that in our brain and pull that out, because there's so much into it. So there's different model. People have come up around that, and there's some famous one, but yeah, so like they call them like a performance measure of manufacturing. So what they see about performance measure is the lead time, manufacturing lead time, working process, the machine utilization, the throughput, the capacity of the factory, the flexibility of the factory, so that's the number of lots, the batch number and things like that. Performability, so how efficient you are, and the quality, so if you have a lot of reject or not, and if you have some reject, how can you optimize it? Is there a way, or did you reach the maximum and you have to live with those quality issue, right? And that's what people call lean manufacturing. It's, again, as I say, it's a willingness of wanting to change model to get those data meaningful for your company. And that's where there is different spots of your company where you need to analyze the data. And there's several techniques. So about mass production, just-in-time, flexible, mass customization. That's what I was speaking as well. Agile, which is a very famous method. We actually use Agile in our own company as a development method. You can use it outside a manufacturing system too, and rapid. So can explore a bit of that. I'm really a fan of the Toyota model, who have really implemented the fourth industrial revolution with the connectivity of the data in their factory, following those principles. And those principles can be decomposed in a few different blocks. We'll look through it, but there's a 5S, there's KAIZEN, there is the standard. So standard is really an important thing as well. Like if everything's compatible, and that's what OMRON working really hard on as well, to get things compatible, easy, trying to throw the complexity of software between different windows and things like that. The reason is that when the standards are coming up, like the USB, for example, everything is easier, and there is like an ecosystem of products that build up around it, which is profitable for everyone. So there is a pull, the takt time, pull flow, man-machine separation, so understanding who's doing what in the job, and if there is a reason why man have to do a certain task rather than a machine. And if it's more productive or valuable that a man do the task rather than a machine. There's JIROKA as well, and the just-in-time. All that basically rise the optimization of quality. You reduce your delivery time and cost through those principles. And Toyota proved it. A lot of factory follow that in Germany as well, that prove it too. It's not a theory, it's just a willingness to go through it. And that's an identification as well, they call the Lean Six Sigma. They show like 8 West example about where you can improve in factory. If you don't know, for instance, which area to focus first, you can look at it like defect, overproduction, waiting, the people that could be used for something better in the company. So not using your people asset as best as possible. There is as well the delivery time and the inventory, all the parts that are traveled to each other, and all the different as well waste of energy around what is running when it shouldn't have to run and things like that. So the 5S principle, for example, is to sort things together, set in order, shine. So basically, make it pretty, make it look good. Get everything standardized so there is no incompatibility. Things are easy from one system to another, and it gives this sustainability. I haven't shown here, but if you look at the 5S method, there's often those photos before, after, and you look at the factory, it's quite shocking to see the conversion. Just by changing this little mentality part of it, saying, okay, we can focus on that, and that doesn't necessarily need any data or things like that. It's just a base principle, and that's why it's at the base. There is because it's a start. It's a start of change of thinking. How can we do things better? Why do we have to run everything because before it was running like that? No, we can improve. We can do something that is top notch. We can develop quality work because we pride of our work, and that's one of the principles. And from that, you naturally go and evolve to saying, okay, yes, it's we can do even better, and we can implement process harvesting the data to understand better our system or complex system to get an optimal manufacturing system. So KAIZEN that lead to us, which is this continuous improvement. So you always try to get better and better and better at it. And again, it's standardize the work, make the problem visible. Like, don't be scared about the problem. Life is full of problems. If we will be scared of the problem, we'll stay in our mother belly. I mean, it shouldn't even be called problem. I think it should be called like a case to resolve or a puzzle or something. It's actually good if there was no problem. We'll be all bored. So it's just about like doing your Sudoku and trying to find a better solution for it, and I think that's exciting, and that's one of the reasons I'm doing what I'm doing. And yeah, so you're looking at countermeasure to be able to not have bias. Look at it and determine the root cause. So yeah, there's often a trap, like you can have just one point of view, and you go down this track and you forget a certain view of it. It's why it's really important to involve a lot of the employee in a factory through the process of it. One, because they embrace it. Second, they feel valued, and they are valuable. So they should be valued. And the third things as well is that they give a point of view of the factories, which is essential, that other people don't necessarily see. So that you are in the sale part, that you are in the production part, that you are in the management parts. Everyone have an essential view of the business, and often there is a big wall between them, and that's the things that need to be put down, work together, because everybody's on the same boat, and everybody need each other. So countermeasure by actually have the freedom of expressing its point of view and all that. It's essential to be able to take advantage of those data. And so then, yeah, you can determine the root cause, put an hypothesis on it, test the hypothesis, implement a solution, and off you go. You go around that. So that's another principle from Toyota, and the HEIJUNKA, which is prediction, flexibility, stability. That's another one, which is give an example there, so that you have 3 model of T-shirts in a factory to do 4 model of T-shirt to do in a factory, and that's your demand per week. And you look at, okay, what's the more efficient way to produce those T-shirts? Well, if you are depending on what you want to do, you would have to produce it differently. It depends on your company, it depends on your needs. And that's the type of things you do with HEIJUNKA, is to see where we can be much more efficient, flexible, get a smaller batch while doing more products. So for instance here, say okay, all those products have a similar base. So why not use some of the base of the basic products to do those extra products as well on the way? And what will be the right sequence to do so that will help us to do it really easily by saving us cost and actually arriving at the same results, but being able to deliver it much quicker. And again, harvesting those data, for instance, will be able to tell you what process take which time and how you can reach this time of production, because you cannot just guess, oh, well, let's put them all together. You would have to get all the data from the machinery to and the process time and the installation time to understand where you can optimize your production system. And I like this little photo that with standardization. Without standardization, basically you are working on a card castle, right? You can have an inflation of improvement, but eventually, as it gets more complex, it will crumble through the awkwardity of having to have so much translation from one language to another, one system to another, and so forth. So standardization is a really important thing, because you cannot have a streamlined system that's flow and doesn't have bottleneck without it, and that's where again the data can help as well. Push-pull versus pull production. So that's the other things as well. When you have all those data, you can predict what's going on. You can directly have feedback from the client telling you, hey, I need that, and getting there rather than being stuck with heaps of inventory in case somebody asks for it. And it's like space, time, cash flow that is stuck in it, it's another way that it drawn companies. Again, data extraction and data mining of it allow you to be able to develop systems this way with production precision, actual consumption, small lot, and low inventory, because you have a much direct line between you and the client. You have a much direct line between the production of the products on the floor and the management. So you can, it's not a risk anymore, it's not a bet, it's knowing we have these products coming, it takes that much time, and here it goes. There's no variability that it's going to take between 1 week and 2 weeks or something like that. You know basically at the minute pretty much what it's going to take if you follow these systems. So here is an example of the pool that I was explaining with how you get the raw material order at a pace that work with the customer orders, and that you have this pull signal coming from the customer that work with the production flow. So the other interesting thing is the takt time. And that's often like saying, okay, there's this part, and this part, and this part of the product. How we do put them together, and same thing again, like with the NG controller, you can say, oh, well, that takes us 15 minutes, that takes us 60 minutes. If we put it all together, what's the final assembly take? Well, it's probably the longest time, or it's if there is a process that is done in between, then you would have to take that in consideration, and then it make it a little bit more complex. Again, those type of things, that's what you can see through it, and you have a real-time history of the raw data or raw material. You say, okay, that took us that much data, that much raw material to build this, you know, we have wasted that much material as well. And you get all those information that allow you to understand how you can improve it and what actually is taking the time and how you can fix it. Another really good way as well to use the data to see what's going on, it's the batch vs single piece flow. So in that example, for instance, if you identify through the data that actually they have been three way you are building some separate part, rather than actually get all the part get built at the same time, rather than storing some inventory here and another inventory here, and get all those pieces together, you would be better off to get them streaming from one side to the other with one type of inventory and one type of raw data, having just the finished good. And you get that by looking at what's the input-output time, what it takes, and measuring accurately the wait time. And you can, I mean, I know that in factory people take a paper sheet, write down the numbers, 10 minutes and things like that, next to the machinery, say how much loads they have done on the paper, but it's daunting. It's daunting for the person that writes them. It's prone to error. It's actually take a lot of extra time for the people to enter all those data if they're thorough in computer, probably on an Excel spreadsheet. Generally, they don't even bother. They just stay on the side. And so why bother just to follow a standard? If you don't do anything with the data, there's no point, right? I mean, yeah, okay, yeah, you follow the standard, yeah, but why not get that useful? Why not getting RFID tags? The person come here, swap his card. When he finished to do the job, he swap his card, and it's done. And then everything go in the SQL database with the data of the machine, with the data of the people, and you can have a meaningful information like how much it actually takes to run a certain process. That's where you see as well the JIROKA principle. And what I was speaking with the writing log, it's a bit the same thing with that. It's like, okay, you know, what's the dollar per machine cost, what's the labor per, sorry, the dollar per product cost, the labor per product cost. I think like this person is just, you know, putting some oranges here in the bucket. How can we improve that? Isn't it should be the machine doing that rather than the man? The man should do something else. And you end up to have an intermediate state where the man watches the machine cycle and press the button for automatic ejection, right? And for ejection. And you look at that and say, why is the man is here? Shouldn't he do something else rather than just looking at the machine? Like, people have a brain that can do much more interesting things than pushing a button. And so that's where you reach the self-monitoring machine, where you improve time, cost, production, and probably can employ 2 people by the money you have saved by implementing a machine for it. And that's another misconception as well people have about automation and all that. Oh, they're going to take our job and all that. Jobs have always been transformed. It's just that you're going to do a different job. But actually, there is more job available than there have ever been. And yeah, people are afraid of that because they don't understand the consequence of it. And this have happened with the first industrial revolution, second industrial revolution, third industrial revolution. History repeats itself. Like, there's a lot of jobs that didn't exist like 20 years, 30 years ago, and people don't even think about it. But there's a lot of things that change, and internet did big change. That's another principle as well, where you can use your data for the just-in-time principle, where you can look at the running hours, speed variation, cycle variation, product design time, the air pressure variation, maintenance alarm, the number of programs that are run in a machinery. If it's that efficient, do you need 2 machinery rather that they run in parallel? Is there a bottleneck there? There's some productions that have to wait because you don't have enough resources to put them together. Did you do a return on investment, looking if it was worth it to improve the productivity? There's enough flow for that that justify it, and so on. So the just-in-time really, it's about saving a lot of cost in storing, having much better production capacity, and as well have a really satisfied client, because the client, from the time he order it and the time he receive it, is really short delays. So, but to do so, again, you need to work on standardization, everything. So there is no translation somewhere that you have to go through. Increase preventive maintenance, implementing total quality control, and all those cameras. That's why they're very famous at the moment. I mean, it's a tremendous good tool to improve and look at quality of the products through the machine. But depending on the product, of course, there's different tests. It might be conductivity test, it could be pressure test, all different type of things. But the main thing is to have a look, saying, okay, what type of tests we can do and how we can improve the quality control. And then harvest all those data and see, well, how many products didn't pass the quality control? Why? Do we have the data to analyze why? Is there a common point between all of those data that are the same default? Is it a design defect? Is it a machine setup defect? Is it And those kind of things you can really analyze it through this data mining and extract some data that would be totally transparent if you would not have those tools. Yeah, so it's the same thing. Like you can really improve the setup time by, how you say, defining a proper process about that's how you do it. This way is a more optimal way to be able to install a mold in a machine, for instance. So something like that. There's actually a tremendous difference sometimes in Japanese factory. I was an American person that was speaking about that, but it was like in 1980s, quite a long time ago. I was just a baby. But already at that time he was saying that when he was visiting a Japanese company, they was setting up a tool machine in 10 minutes when at his factory they was taking 2 hours. There's those type of tremendous difference in how much efficiency you can put into setting up the same tool that make all the difference. And it's all about being methodical and training. Training is really important too. So yeah, there's all those different type of things. Change to smaller machine, maybe like if you do smaller batch, but with more machine, maybe that's a solution. I mean, there's all those different things that can make you provide more regularly system to clients quicker, as well. Like look with the providers. What can be automatized, or what's the bottleneck between ordering the product so it can be improved. The last things I want to speak about is what they call total productivity maintenance, and it's basically being able to have a preventive maintenance, and that's where as well all those data are so important. And here again, it's another building with some principles that help to have this system. And of course, you know, cleanliness, order, discipline, it's always have been the first things. You know, if you are organized, you know where things are, and things last longer. As well, cooperation and willingness to get better is essential. From that, you know, having some of the data that's coming in, you could have an alert automatically that tells you, oh, this machinery have run out of its maximum hours before its scheduled maintenance. So then, say, okay, well, no, don't have production this day. Let's do the maintenance of this machinery this day, rather than you get a breakdown in the middle of it and you're losing so much money when you could have just say, well, let's plan it there, and because, and as well, it's avoid as well to say, oh, we're going to schedule it every 2 months, so like this we're sure. When actually the machine doesn't run that much and doesn't need as much maintenance either. So it's an optimization because you know actually exactly how much hour the machine have run. And if it ran at different speed, you could know that as well, and you could know how much wearing there's more about it and things like that. You can see my function parts as well. You can, if there's some friction and certain things of this nature, you can have a slowdown on the machinery, a rise in torque for the motor. And that can be, you can put some level of alarm on it, saying, well, it seems that there's a repetition of heavy loading when it shouldn't be. on those type of motor, maybe the bearing have a problem, or maybe this have a problem, and it's going to die off very soon. So let's do a preventive maintenance, assess it, repair it, and save a lot of money. As well, spare parts. So because when something wear off, it does wear off the rest of it, which is around it, and eventually you end up to change one thing, and the next things, and you say, "Oh, this machinery is terrible. It's always have so much problem with it. We have always to change all those things." But it's probably because initially the maintenance haven't been done properly. There's always lemon, right? But the thing is that there is often a cause of why there's several parts that have wear in a single machinery, and it's often because the initial part have done a type of domino effect on it. And so, yeah, as a result, you increase the production running time. You can look as well at the speed variation of the machinery, seeing why you run a product quicker than another, and some reason. There's certain data certain people in the factory know, but never be able to communicate to other people in the factory. And that's another way why the measurement allow to have democratized knowledge about certain things. They will never been able to have a clue about it, and if they would have a clue about it, they would be in position to make decision and change about it. So that's for me anyway. I'd like to thank you, and if you have any question, welcome to ask.